Hello everyone, my name is Roberto Viscotelli and I work in quality assurance here in fluorseals. And today I'm the speaker for this webinar that is all about certification, material approval, and certificate. During the course of this webinar, I will give you an overview of all the certification that fluorseals products have. We will briefly go through each and every, and in some cases, we will delve a little bit into the testing requirements and the testing method. So I will try to give you some insight about them, and I hope you get some added values out of it. In the last part of this webinar, we will talk about certificate. I will explain to you the difference between each of them, and I will give you a real example of a 3.2 certificate, a very quick example of a real certificate. And to conclude this presentation, I will talk about what analysis we as a quality department can perform and what kind of documentation we can provide beyond the simple certificate. Okay. So a little bit of an introduction to the PTFE world. As many of you already know, PTFE has many unique properties, and this is the reason why it's applied in a wide variety of different applications, different industry with different requirements. PTFE chemical resistance is top-notch. It's basically impervious to every known substances, with a couple of exceptions, so highly reactive alkali metal, so like sodium, potassium, something like that, and very strong fluorinating agents. And this is already very aggressive media. Generally speaking, PTFE is an extremely inert polymer. It has good... Generally speaking, PTFE has good sliding properties. Its coefficient of friction is the third lowest among all known material, and it's a very good electrical insulator. And this is just to name a few properties that makes PTFE applicable in a so vast and different industry. Today, I will mainly talk about PTFE, so I will mainly refer to that, but this is generally true for all fluoropolymer and for PIC too. So every one of them have its own sets of strengths and weaknesses, and I can cover the weaknesses of each other. But today I will mainly refer to that. Moving on to the real part of the real topic today. So what is certification? So product certification or product qualification is the process of certifying that a certain products have passed performance and quality assurance test. And by passing this test, this product meets the requirements or the qualification criteria that are set in a standard, regulation, a contract, whatever. Certification exists to ensure safe and consistent performance across the same industry and across the world, so even geographically. So standards have been developed to be some form of assurance to customer that this material have the right balance of properties, and that these properties are consistent even in different batches, and that these properties are still there during its required lifetime. So, generally speaking, the process of certification follow 4 steps. Our first steps is the application, where we normally send the specimen, provide all the documentation, and even provide all the necessary information. Then there is an evaluation phase where the data, the documentation, and the tests are done, and they basically evaluate if your product meets the requirement of this of the standard of the regulation. And then there is a decision phase where they do an extra review of the data they have and decide if your product deserve the mark or the approval, or if it needs some kinds of limitation or some kinds of limitation or constraints on the application or on the material itself. So, and then there is somewhat surveillance phase where they basically check if your product keeps the same quality level across every year or every sometimes. And so they want to see if they want to check if your material keeps its qualification criteria and satisfy the requirements of the standard. And this is done in different way. Today we will see with some certification required yearly audit, some expired, or some have every certification have its own sets of rules. So the surveillance, it's a bit different. The first industry that we're going to talk about today, it's the drinking water one. So water is classifiable as drinking when it doesn't contain any microorganism or any substances that make it danger to human health. This makes the drinking water, one of the most controlled products in the entire world. This is especially important because material that comes in contact with water can leach substances or can grow bacteria, mold, that kinds of stuff, and this can be a danger. So it can be harmful to human health or to the environment. And in some cases, this can even lead to a change in the quality of the water. So not only it's the danger, or not only it's the safeness of water here, but even the quality of the water. So clarity, color, transparency, or odor. Okay. The first certification in drinking water, it's the RAS. RAS, it's the Water Regulation Advisory Scheme. It's a conformance mark that is given by the UK's water suppliers. So the bodies that gives you the approval, it's made by all the UK's water supplier. This regulation is about water fitting, plumbing system, and whatever material that comes in contact with water that supplied or be supplied from the public water. So this is basically a state law. The approval system also covers non-metallic component and material, and this is the reason why we're talking about it today, such as PTFE washers and gaskets, which undergo testing to see how the material affects the water and if it affects the water. So the testing is done with an odor and flavor test that is done at multiple temperature and a cytotoxicity test to give you a more objective analysis of the material. As many of the following certification about drinking water, BRAS lasts for 5 years. And here we have a short list of our approved material. So moving on to the other side of the pond, we have the NSF certification, so the NSF 61. This is a standard for the US and it's again related to water treatment and drinking water consumption. The requirements here are very severe and very stringent, and so any supplier that has the approval of a NSF use it as a distinction mark for its product. Testing here is done vary from a very basic cold water test using water at different pH levels, so different acidity level, up to a more complete full chemical certification. This depends on the surface area that comes in contact with water, and the temperature that where the material is used. So this depends on both and on the material that we want to certify, that we want to which we want to get the approval. The NSF is different from the other certification because they don't have a 5-year expiration date. Every year they do an audit. So in that sense, it's a true product certification. So every year they came here, they audit us, and they want to see if you still complies with the requirements of the standard. Okay, so moving back to Europe, we've got the regulation for the French market. Here, this is a state law, so it's a compulsory requirement for using any material in the drinking water industry in France. This is compulsory since 2006. Again, as for the NSF, the standard divides the products based on the surface area that comes in contact with water, so the exposed area, and the temperature. They divide the products in 4 classes, so up to 3 square centimeter per liter and to 230 square centimeter per liter. This, as many of the other certification for drinking water, lasts for 5 years. Okay. Then we've got the drinking water certification for the German market. Here I've gathered them together in a single slide because but they are in reality 2 different certifications. The KTW, it's the basic one, and the VU and the W270 certification is an addition you can make because it requires you to have the same because it requires you to have the approval of the KTW as a requirement. This is one of the most restrictive in terms of composition. As once granted, they both last for 5 years. The testing here, at first, they ask you a full disclosure of the recipe of your products. So they want to know every ingredient that is used in this product, or in your material, and they want to see if this is in accordance with the UBA's guidelines. The UBA is the German Environmental Agency. Once that is being set, they start with the migration test. This is done over a period of 10 days. The basic temperature is room temperature. Then you can add 60 and 85 degrees. So basically lukewarm and hot water. And every extra testing that comes from the recipe assessment needs to be done. Then for the W270 certification, you can add a microbial growth test where they basically expose your material to water for multiple months, up to 3-4 months. And then we want to see if any microorganism, any microbial mold, everything grows on it. If the test is passed, they also give you the approbation of the W270. Then we move to the food industry, which is the other side. We've got 2 possibilities here with a third one. The European standard, which is the EU 1935, which is specified for plastic by the 10/2011, and then we have the FDA. And for dairy equipment, for dairy product, we have the 3A as an addition. So the EU regulation, so the 10/2011 leaves into the frame of the 1935. So you have to comply with both to get the food industry approval. They are related to any kinds of material that comes in contact with food. So the MOCA, which is the Italian term for the food contact material, It's a certification that is used for all manufacturer of product that comes in contact with food. It certifies that the entire supply chain complies with this standard. This kinds of test does not require renewal. A little parenthesis to open here. The fact that they don't require the renewal does not mean that they don't do surveillance, and the renewal is valid as long as the material is the same, so the basic raw material use is the same, and that the manufacturing process still stands. So as long as everything is the same, they don't require a renewal. But again, they as a regulation, as a state, in European regulation, they do audit and they can inspect us. Then for the American market, we got the FDA approval. The FDA is basically the Food and Drug Administration, which is an agency of the United States Department. Again, this kinds of test does not require a renewal, and as I've already said, stands again. The difference between the two standards are the testing methods and the testing methods and tests you have to done. Here we have a very quick, very brief overview of what testing is required. They both share food simulant testing, so migration test done with different substances at different temperature for different time. But then again, the European 10, the EU 10, required multiple testings, so specific migration, for example, of ion like barium, cobalt, up to an olfactory test. While the FDA simply requires you to do your migration test, a fluoride extractives, and a ER. The infrared is there to assess your material because the infrared gives you a unique fingerprint for each material. So the spectra is unique for every material. And this obviously is, I'm talking about PDFE. Then the last option we got for the food industry, the 3A. The 3A sanitary standard is an American organization that serves the public by developing standard for sanitation in dairy used equipment. The focus here is granting integrity of the process equipment and the system. One of the basic requirements of the 3A is the FDA, so that is already been set by them. The goal of the 3A sanitary standard is basically to protect the food from contamination and ensure that all the products and all the parts of an assembly could be deep cleaned. This because if anything cannot be easily cleaned, it can lead to growth of microorganism, mold, fungi, bacteria, everything. The testing here is done by using an accelerated cleaning substances to see how your material behave when in contact with them. These kinds of tests, as for the other, these kinds of tests does not require a renewal. Then we move to the medical grades, the medical industry. Here, again, we have a couple of options. The first one is for the American market, so it's the USP. USP is the US Pharmacopeia Convention. They aim to create standard for medication, dietary supplement, and in general for the healthcare industry in general. So they do publish compatibility protocol for plastics and polymer when used in any medical devices that can comes in contact with the body, with the human. The testing here for the USP class 6, the USP divides their classes they divide their certification in 6 classes, from the lowest, which is class 1, up to the hardest, which is the class 6, and the most useful. It's state that your material is completely inert with the human body. The testing for the class 6 include an in vitro cytotoxicity test and 3 in vivo tests to see how your material will behave when in contact with a live animal, basically. These kinds of tests required a lot of time. The in vivo test requires that the live animal, which is often a rabbit or a mice, needs to be quarantined for a week, and then they do the testing, but it can last up to 3-4 days. So to do this kinds of testing, it's required up to 10 days, 2 weeks. This kinds of test does not require a renewal. And we have a couple of options here for fluorseals products, which is the Flutec P2000, which is our virgin PTFE, and the Flutec P3000, which is our modified PTFE. And both have the approval, so are certified S.p.A class 6. Here is just to show you all the tests that needs to be done, the kinds of substances that are used for the different classes. Okay. Then we got the other option for the medical industry, which is the ISO 10993. This is a standard that uses systemic toxicity and cutaneous reactivity testing to assess whether your material can be used as a medical device. So in a medical device, the ISO divide the devices based on the nature and the duration of the contact with the body. So if here we have a very basic tables. It shows you that for anything that have a limited impact with the body, so for example, something that comes in contact with the skin for a limited amount of time, the testing required are much less severe, while for any implanted device, so for example, something like a prosthetics, hip replacement, something like that comes in contact with the body for a very long time, so semi-permanently or permanently, basically, the testing are much more severe. And this, depending on the kinds of the device that you need to develop could be much more extensive than necessary. It can be too much, basically. These kinds of tests does not require a renewal. In these kinds, for this approval, our only material is the P2000, which is the only one approved by the ISO 10993. Then we move to the oil and gas industry. The NORSOK standard, so the NORSOK M710, is not a regulation per se, it's an industry standard that has been developed by the Norwegian petroleum industry. So they set requirements for non-metallic sealing material for the manufacture of them. The NORSOK is used in any equipment that comes into the oil and gas industry. So anything that goes from up to the well completion in oil rig, on oil refinery, in system valves, everything that comes in contact with the oil or any kinds of similar fluid. Here, the testing. So the testing here requires you to choose between two fluids. One is called sweet fluid and one is called the sour fluid. The difference between each of them is that the sour fluid contains the hydrogen sulfides, while the rest of the composition is the same. So the base is made by aromatic and aliphatic hydrocarbon, and then we have a small percentage of the hydrogen sulfide. If you got the certification for the sour fluid, both are get. So if your sour fluid, if your material is approved with a sour fluid, you got the certification for even for the sweet one. The testing here requires you, it's done at very high temperature, multiple temperature for a long time. The temperature is much higher than the real application required. This is done for two reasons. One is to make the sour fluid a little bit more aggressive and to make the material more receptive to it. And the second reason is because to apply the Arrhenius model. The Arrhenius model is based on the time temperature superposition principle, which is a principle that is a very well-known principle in polymer science. This states that any polymer that has been tested at high temperature for a certain amount of time So it basically states that for any generic polymer, time and temperature are laced together. So if I test my material at a high temperature but for a low time, I can use this data to predict how my material will behave in a lower temperature for a much longer time. So I can use the data that I gather doing testing at multiple temperature to foresee how my material will behave in 5, 10, 15, 20 years. The idea here is to assess how your material properties will changes during aging while exposed to a quite aggressive media. The temperature and the time is chosen by the manufacturer. It's chosen by the manufacturer, and that's it. These kinds of results are used to predict service life again, because they want to know how your material will behave in a very, very long time, so up to 20, 15 years, something like that. Then the other option, it's the AP6A. It's an international standard it's the American standard. It's an international standard. Is similar to the NORSOC, while the NORSOC is probably the most severe of the two. This kind of test does not require the renewal. The testing here is done. It's very similar to what we do for the NORSOC M710. They take a specimen and they immerse it in a sour fluid, so in a hydrogen disulfide containing fluid, and we want to see how your material change its properties over time. Here the temperature is only one, so you have only to choose one temperature. The exposition time is much lower. For the NORSOC, the exposition time is up to 1.5 months, while for the AP6A it's about a week. Here in the top figure you can see the test specimen before the immersion and after the immersion in the fluid. So they immerse the specimen into the fluid, and every now and then they take one out and test it to see how your material properties degrade over time. Then for sealing material, we have the BAM approval. BAM it's the Federal Institute for Material Research and Testing. It's a German institute. It's a government-based institution. They do that sets out safety standard for the German market, but in the last years it has become even always more important, and so it's quickly become a benchmark for the global it's a benchmark for compatibility testing between sealing material and liquid or gaseous oxygen. So we do BAM testings. We get the approval of BAM for the compatibility of our material when used as a seal element with liquid or gaseous oxygen. The testing method is always concerned about the safety of the application. One quick example of the testing they can done: they took the material, they wrongly mounted it in a flange, so one piece, so the material protrude to the inside of the tube, and they set it aflame. And we want to see if the material spread the flames to the metal or if it keeps the sealing as tightly as before. So again, this is to ensure safety of the application, the safety of the material. Here we have the results, a result example that the BAM test report. So in our case, we got the material tested for two temperatures, so up to 60 degrees and up to 250 degrees. The difference here is the maximum allowed oxygen pressure to be used in a safe application. So up to 40 bar, up to 30 bar. Here we have a list of here you can see the list of our FluTech that it's approved by BAM, so that has been tested and been approved as a material to be as a compatible material for oxygen. Then for the last certification of this webinar, we talk about the civil engineering one. So the EN 1337-2. This is a certification that concerns the sliding element in a structural bearing. So a structural bearing is basically a bearing that needs to be mounted on a bridge and support the bridge and let it move. So the sliding element there is there to let the bridge move, the bridge pier to move, slide a little bit with minimum friction. The testing here is very important. The requirements are for both mechanical properties and frictional resistance test. The EN 1337 in its standard states that only pure virgin PTFE is the approved material by BAM. So the only mentioned material is pure virgin PTFE. Our material of choice for this kinds of application, it's the P2010. This has longly been tested by the material testing laboratory of the Politecnico di Milano, which is our inspector and the approver of our material. So now we move to the last part of this webinar, and we talk about a little bit about inspection documents. The EN 10204 divided certificates in two major categories: the non-specific inspection based and the specific inspection based. The idea there is that for non-specific inspection, the manufacturer carried out inspection, so with its own procedure to assess if the products that are being produced with the same product specification and made with the same manufacturing process complies with the requirements of the order. Here, the most important part to keep in mind is that the product inspected are not necessarily the product that are actually supplied. While for the specific inspection, again, the inspection is carried out by the manufacturer based on product specification on parts that are going to be supplied or a test unit of which these products are part of. So the inspection needs to be carried out on the same batches, basically, that are going to be supplied. Okay, so for non-specific inspection, we have a couple of possibilities. The first one is the declaration of compliance. So generally speaking, simply speaking, it's a 2.1 certificate. This is just a document that states that our material complies with the requirements of the order without including any test results whatsoever. While we have the test report type 2.2, here is again a document in which we state that our the product supplies complies with the requirements of the order, but we provide testing results, so test results that are based on non-specific inspection, so that are done on every batches that is done with the same manufacturing process with the same raw material. Then for specific inspection, we have two possibilities. These are the top quality certificate we can issue. The 3.1, which requires that the manufacturer test that the manufacturer test the same batch that are supplied, so the same product that are supplied or a part of it, and in which we add with the certificate we add test result. So again, these kinds of tests are defined by product certification, product specification, regulation, or requirements based on the order. Then we have the type 3.2. This is the highest quality level we can get. Here is basically just a 3.1, but the caveat here is that the inspection is not done only by the manufacturer, but even by a a purchaser inspector, so a purchaser representative, or an inspector that has been designed by official regulation. And here, as for the for the other certificate, we supply test results. This is a kind of certificate that we issue with our dimple sheets, which is part of the sliding element of a structural bearing. As I've already said, the EN 1337 requires that every material requires that to comply, every material needs to come with a 3.2 certificate. So we got our dimple sheet tested by the Politecnico di Milano. They come here, the inspector comes here from the same batches, which is up to 500 kilograms of sheet. They choose 4 sheet and they test all of them. And to issue a certificate, so to get their approval, every test they done needs to be positive. So every test have to be passed. So to conclude this presentation, I'll show you a little bit of what we as a quality department can, what kinds of analysis we can perform, and what kinds of analysis we can perform. We are fully equipped to do mechanical tests up to from tensile strength up to hardness, specific gravity, so the basic mechanical test. We can do some electrical controls, for example, spark test to detect pinhole on tape, on films. Our laboratories are well equipped to do thermal analysis, for example, TGA, DSC. We can do electron microscopy and microscopic measurement. Then we have the equipment and the capabilities to do dimensional analysis on finished parts. So we can both on finished part and on the raw material. So, for example, powder granulometry analysis, or we can do 3D measurement on finished part with our CMM or with our automatic machine. So we are fully equipped to do that kinds of analysis. Here in Gumello, we got a state-of-the-art Zeiss CMM for 3D measurement. And this is just to show you a little bit of what kinds of documentation we can provide beyond the certificate. So we are more than able to draw up control plans. We can do PPAP. We can do statistical process control, and we have the equipment to do automatic selection and automatic control for finished part. And we are in contact with external laboratories and universities, like, for example, the Politecnico di Milano, to do any kinds of tests or developing new material or to perform tests that are not easy to be done. And all the testing that we can do can be performed with according to multiple standards, like STM, ISO, DIN, MS, etc., etc. And this is it. I have a great day. Take care and bye-bye.